Lab10 DC motor. Here's the trainer configuration. It's very similar to how we had in the stepper motor, except on this configuration we still have our dip switch, and what our dip switch is set up for is 3 inputs going to port B0, B1, and B2 once again. However, with the DC motor we will have direction control with switch 1 and switch 2, much like we did with the stepper motor, and switch 3 will give us our speed control. Now, a little bit of difference here in that this particular configuration, as far as outputs go, we're going to have only 2 outputs from port B, because in this configuration we do have to use an H bridge, especially to get DC motor control, where we have to swap the polarity going to the DC motor. So we're coming down with that to this header where we're connected. It's important to get the wiring correctly, and it does go through opto isolation. We want to keep our microcontroller voltage completely separated from the high voltage and all the noise that goes along with DC motors. You can see over here we're using an H bridge. It's going to be important that you have this thing wired up properly, because you could get some short circuit if you're not careful. We'll begin down here where our 12-volt input comes in, just like it did previously with the stepper motors, but now we're coming all the way down to another section, down where the H bridge is. There's only 2 of these MOSFETs on at any one time, and of course we've got a switching MOSFET up at the top we'll show you in a moment that actually swaps the direction going into it, and there's also LED indicators to show which MOSFETs are on at any given time. So we'll go ahead and power this thing up, and let me slide just a little bit this way and come down and watch the DC motor. Okay, I don't know, it's going to be hard to see the DC motor, but you can see the indicator LEDs. It's going in one direction now. It's going in the one direction. We just increased the speed. You can see the other indicator LEDs going in the opposite direction. And of course, if both of the switches are up, it does pulse back and forth. Going to give you an idea how that operates. Now on the slow speed, since we're dealing with motors, if you watch these LEDs, you're looking at some of the counter EMF. Whenever you have something spinning and you release power to it, that counter EMF causes those LED indicators to glow just a little bit. But this is the proper operation, where with digital input we're controlling a high voltage device with some ample currents. That concludes this Lab 10.